off OSX.
They've been turned off. You gotta get that. Yeah.
Alright, so you can be right?
No, I'm gonna do it. He's gonna observe.
Okay.
And then if there's an emergency that needs my attention, then it's unlikely to happen.
welcome the Dev Shop. I have an announcement before we start the presentations. So the folks in the first few rows will be visible by camera. So if you're camera shy for any reason, feel free to take this time to move to the back of the room. And folks who are coming in the back, feel free to grab additional seats in the room and fill that up. Cool. We will be commencing shortly. All right. Oh. In a little while, can you check to see if there's audio?
What?
In a little while.
Yeah.
Hello, everyone. Welcome to Dev Shop. This is our 14th, possibly, Dev Shop, is it? Yeah, we're starting to lose count. Our first talk today, our first featured talk, is a highly anticipated one. Today we have David Fetterman and Zoltan Olah. And David is the VP of Engineering at Famous and formerly the Mobile Engineering Manager at Facebook. And Zoltan is a developer at Percolate Studios who brought you the new Atmosphere UI. I hope some of you saw that from last Dev Shop. And Famous and Percolate have teamed up to do a Famous plus Meteor integration. So to tell you more about that, David and Zoltan.
Is this thing hooked up? Cool. So I'm Zoltan, and I don't know if you can hear that.
Yes.
Yeah. I'm a partner and engineer at Percolate Studio, and yeah, we build real-time web apps with amazing clients. And this is Dave Fetterman,
Hey.
VP of Engineering at Famous. You guys build crazy cool JavaScript accelerated UI.
How many of you guys have heard of Famous? How many of you guys have heard of Meteor? Oh man, I got some catching up to do. How many of you guys have heard of Facebook Paper? Have you seen the new Facebook Paper application? Why is that significant? Well, the Paper app's beautiful, right? It's like a Flipboard style interaction that's just absolutely gorgeous. And when you look at it, it's pretty cool. It's composed of a small number of interactions that actually compose into something more, a lot more interesting. So you have your typical elements of something like a scroll view, which you can find in anything from your basic, Twitter table view controller style application up to the very most sophisticated. You have a lot of interesting transitions here where, let's say, you are pulling into view of more of a detail view. You can watch the photo sort of expand, the text sort of opacitates in and out, and then of course you can apply scroll view in a vertical way as well. And something even that people don't expect, but unless you work at Flipboard, this kind of interaction here. We're actually digging into something by this really cool semi-3D positioning of tiles in space. Now, these things are impressive because people didn't even think until recently that you could really pull this off, even in something as sophisticated as UIKit or Quartz Core on the iOS side in the UI framework. But really, when you look at this kind of stuff, the GPU eats these kind of interactions up. The GPU essentially deals with something called surfaces. It deals with something called textures, which are essentially 2D surfaces that it moves and manipulates in space, and it's really, really good at it. When you program in iOS, you're basically all the way at the bottom, you end up dealing with surfaces that are moved and manipulated very quickly in the GPU. And when you do this in web as well, you end up in the same spot. The trick is that for the most part, people haven't written a UI development framework that takes advantage of talking right to the GPU to deliver this kind of thing. So Facebook Paper is this gorgeous application written entirely in Quartz Core in iOS. But Famebook, as you see here, is essentially the same thing written entirely in web technology. So you guys are obviously into web technology. You're looking for a way to make your jobs as application and site developers a lot easier by using a framework like Meteor, a next generation system that solves a lot of the problems that are kind of just like thorny and always come up when you're trying to build something sophisticated. And that's true definitely on the back end for Meteor. And Famous does a lot of the same things, but on the front end. So something that once was only achievable in Quartz Core, or really in like deep native technology, is achievable actually in JavaScript and web technology. Now, why this is so surprising, Zoltan's going to show you right now.
Thank you. So allow me to transfer this across. All right, so Mosaic, 1993. That's when it came out. That's when the web arguably started. But since 1993, it's grown up. And it's evolved from being just a purely document delivery platform to being like a feature-rich application platform. And that's no small feat, but there's a problem. And that problem is that DOM layout is really slow. And HTML, CSS has gotten so complex over the years that you can render just about anything you want, but it takes the browsers quite a lot of work to actually figure out how to lay that out using the DOM. And there's also no performant way to animate in JavaScript, so you have to use CSS. And CSS3 is great for doing animations, but it's pretty limited, and also the performance can be sketchy. It's unpredictable. So Famous sidesteps the DOM layout altogether and renders to the GPU directly. And to do so performantly, the entire Famous scene is built in JavaScript. And that also means that you can use JavaScript to control way more complicated layouts dynamically based on where things are than you could in HTML. And Meteor, I mean, of course, we all love Meteor. It's a great real-time platform for building like trivially easy, for building really complex apps and deploying them in a trivially easy way. And you get a really rich ecosystem, you get live data, you get reactivity, auth, routing, package management, all of that like good stuff that we want to use. And thanks to its declarative syntax, it's really quick and easy to write Meteor apps. And because you're writing such few lines of code, and I find this in my daily development, I seem to end up with like much fewer bugs. So let's get these two frameworks working together. And it turns out it's actually really easy to do, and they complement each other really well.
Right, so Meteor is a very principled framework, right? You do things right. And when you do things right, you get things simple, and you get things very performant. Famous has a number of principles as well. In order to build that JavaScript-based application that actually feels like a 60 frame per second application, and you could actually deploy to something like an app store, you have to follow a number of principles. And we'll talk about these a little throughout the lecture, but first of all, you want to treat your application like an app. Don't cram a document into it and pretend that the layout of the browser is going to give you Facebook paper. It's just not going to happen. Second, talk right to the GPU. When you're actually able to manipulate those textures in the GPU in a performant way, sidestepping browser layout, you're going to be able to get that juicy feel, that real 60 frame per second on whatever device you're working on. Third, you want to use physics and natural motion to actually compose these things. If you build just something that's really fast, but like it flies around and feels like it's out of control, it's not going to be enjoyable anyway. So janky and like stuttering is one thing, but something that doesn't feel natural. It doesn't feel like you could actually, when you touch it, it responds to you. That's going to be a problem. So you want to use physics for natural motion. And finally, get it ready for WebGL, because this is going to be, when we're talking about this maybe a year from now, WebGL is going to be available on all the devices you use now, and people will be talking about how do I build something in 3D instead of just with DOM. So anyway, we'll go into some of the deep notions, or I guess the core notions of what it means to build in Famous, and that's one reason why we brought Zoltan on in our private beta to see how these things work together.
So the scene graph is really important. That's what you're going to be using to lay out your Famous apps and to build the UI. So we've got maybe an example app here, and that's composed of surfaces, right? Famous surfaces. And so the header there might be a surface, this bottom section might be a surface, and in fact the background might just be a background image, but it could be a surface as well.
And this is in contrast to what you're going to see when you build traditional web applications, where you're basically inserting DOM, which represents at once a hierarchy, the content, as well as the structure that the browser is going to try to interpret as a document, lay it out its own way, and jankify your whole experience. So surfaces mapping directly to GPU textures and managed pristinely by a very principled architecture, that's how you're going to get that performance.
But surfaces are just divs at the end of the day. So you throw your own HTML content into surfaces.
You make it seem so simple.
Yeah.
Yeah.
I mean, what can I say? I think it is. I think everyone's going to find it pretty simple and lovely, really. So the other thing that's important to understand is transforms. So transforms act on surfaces to position them in the scene graph.
Yeah, so a surface, when we're looking at this paper example, all these pieces of HTML content that move atomically, where you don't break the pieces apart, that's a surface. That goes right to the GPU, and the GPU says, OK, I got this, and then it moves it around. The transform is what the GPU uses, essentially a matrix, to say where I'm going to position it on the screen, scale, skew, rotate, and even opacitate. So when you combine all those things, those are the atoms that actually build up into the giant supermolecule that is your application. So at the very end of the day, a performant application is simply built off of the surfaces, the displayed pieces of GPU content, and the transforms that move them around.
And transitions allow transforms to act as animations too. So let's see some code.
Should I pretend like I'm coding with you?
Yeah, you might as well. If you see any mistakes, just let me know. Not that there will be, so because it's so simple. So here we have, on the right, we have a surface. And on the left is the code that generates that surface. And this is a Meteor project. And it has the Famous package added. But apart from that, it's just a vanilla Meteor project. And so you can see, this is all I've had to do to render a surface to the page. So next up, we're going to do something a little bit more complicated. So we take that surface, And we're going to set some transforms and set an easing curve transition. And when we click the surface, we're simply going to apply that transition. So as you can see, we've affected some animation, and we've done it through JavaScript.
Not so hard.
Not so hard.
Got that, camera guy?
One page of code. So I want to dive into the physics engine a little bit. So in this next example, I've created a particle with some velocity and mass, and I've created a spring, which is part of the physics engine as well, and I've combined them all together in the scene graph. The really interesting lines of code are here, where I define a force, and I just simply apply it to the surface. So I'm doing that in the Z plane. So you can see what that does is when I click that surface, it behaves as a spring, right? Based on physics principles.
So why is that more interesting than just simply adding a CSS3 transition? Well, there's a lot of reasons, one of which is they're infinitely composable, right? So if you basically build your whole scene into this vector field, you can have this thing happening at the same time as this thing happening at the same time as this thing. So you can stop animations in the middle. Instead of basically building your entire, the entire space of what a user could use out of a bunch of like one-dimensional transforms, you're actually building a composed system where you can stop and move it like the very real time, so that 60 frames per second is not a problem at all.
So I'm going to ditch that physics in the animation for the time being.
Okay.
Really cool as it is, but it's actually still there in the background, right? Because what I'm doing now is I've taken this scroll view component, and I've just thrown a bunch of surfaces, just as I was creating them previously, and here I am in a for loop, pushing those surfaces into an array, and then I sequence the scroll view from those surfaces. And what that's doing is it's building this scrollable list here, and it's a famous scroll view. And if you notice it bouncing at the end, that's famous doing the bouncing, right? So that's not the browser. So famous is actually is able to do the same thing that iOS does, all in JavaScript and all rendering it through the browser.
You guys might say VFD for the kids, big fancy deal, but it's only been a few years since physics has actually entered the consciousness of the applications that we use. Something like the iOS the entire UI toolkit, the kind of apps that we use, a lot of that fluid, delicious motion is actually because they've introduced concepts like springs and very recently torque into the system. So in order to build something that feels like iOS, you'd want to use the principles of iOS. And by the way, I'm not recommending you want to build an ersatz iOS application. You want to build something that makes people feel the same way they feel when they feel a native application, and that is good.
I think so. I think that's really good when you do that on the web. Yeah. So who's heard of the leaderboard example app? Who's seen the leaderboard example app?
For Meteor, it's like one of the Hello World apps.
Yeah. So we've taken.
I guess they graduated right into like level 2.
Yeah, they could have seen the to-dos list app first.
Yeah.
That's pretty neat. So anyway, we've taken that previous example, and rather than using, and sorry, I should say that I've thrown the leaderboard code into this vanilla Meteor project, but really I've done very little else, nothing else. So rather than creating the surfaces in a for loop, now I'm using this cursor to array function to create the surfaces. And this is where some of that awesome power of Meteor comes into play, because as you can see, I'm just using a find to return a cursor, and I'm mapping that to the surfaces array, and then just having this scroll view sequence over that, just like magic. And the cursor to array function is actually really, really basic, right? It just hooks into those event handlers that you get from an observe, and it modifies that array in place. And here's where you could introduce animations when data arrives down the wire, or you could make room in your list for the item that's coming up, or do any number of fancy things.
So is this essentially the whole shim between the data flow aspects of Meteor and the visualization aspects of
Exactly. And it's half the shim, not quite the whole shim. We're getting to the rest of the shim soon. Now, in fact. So in this step, I've done really not a whole lot more, except I've added this header footer layout, and you can see down the bottom we've got the footer. And rather than rather than setting the content of a surface just as a string with HTML in it, what I'm going to do is complete the picture and render a Meteor template onto the face of that surface. And in fact, I'm doing the same thing up here too. So this is the same function that I was using previously to create these surfaces. But now I'm rendering the player template into the surfaces. And that's it. And I'm still using that same fundamental code that powers the leaderboard example. So all the logic is still exactly the same, and it's Meteor. And it's using the session, and it's using the collection, just as you would normally, except it's using Famous now to draw the UI, to draw the scene. So you can use Famous for what it's good at, which is all this fancy, crazy animation and physics.
You're welcome.
Thank you. I thought you might have something to add, but you're silent. So I'm going to go over here now, and this is another one of the examples. You may have seen it. It's the wordplay example. And what I want to show you is when you've got a complex Meteor app that you've already built, and Famous comes out in 45 days, and you're like, wow, I really want to use this in my app. So how much work is it going to be? So it turns out that it's not that much work, and actually it works really, really well. What you have to do, though, is you have to split your templates apart and put them on separate surfaces, and then have Famous create that scene graph with the surfaces. And then your templates will all talk to each other as normal through the session and through the collections. So I've just added a little bit of pizzazz to the wordplay app, and that's all I've done. And
So remember, like that surfaces are essentially what the GPU manages atomically. And another way to look at that is that which moves independently. So it's pretty obvious what the surfaces in this example are. And this is a pretty simple example, but it illustrates and can be applied directly to more complicated things like a Pinterest or a Facebook or a Yelp or a Paper or whatever apps that you guys are thinking about building.
Exactly. So really, the two very important pieces of this puzzle are using Observe to hook into your collections and doing something intelligent as they change. So creating surfaces in whatever way you want and applying animations and transforms there. And then using Meteor.render to render Meteor templates reactively onto the surface, onto your surfaces, rather than defining them via code. And there's another app that I forgot to show you that I'll show you really quick.
Oh yeah, I did.
And as soon as I saw this magic just like hooked together, I was wondering, like, is this performant? Is this gonna work fast, right? And so this is another very simple app that introduces some physics. But watch this. This is really cool. And then I can type. But this is a fully functional Meteor app, and you can see.
As long as you time it right, you're hitting stuff.
You can see it's doing routing as well while the animations happen. So
anything
my mind
powerful
was
enough to
blown
build
at
something
this point.
beautiful is powerful enough to build something ridiculous as well.
Exactly. So, do we have time left?
Yeah, we have 1 minute and 10 seconds left. I just want to make sure that you guys took away what our principles of Famous are, because again, the Meteor principles are so ingrained in you guys. Again, if you're building something using JavaScript that's going to be mind-blowing, inspiring, the kind of thing that you'd want to use, you want to first of all treat your JavaScript like you're building an app, not like you're building a web document. You want to talk right to the GPU, and which is actually pretty simple to do with CSS if you do it right. And you want to use natural motion. Physics is probably the best way to do that. It's composable, it's configurable, and it's actually pretty easy to use once you get the hang of it, instead of writing like quadratic curves or something like that. One other thing that I wanted to say while I have 27 seconds left, thank you for holding that up, is I wanted to show you one thing that we should be ready for. And so right now we're talking about building applications on the web using the constraints that we have. Right, the constraints primarily of what the document's going to do when you insert DOM into the system in the wrong way. There we go. And this works on iOS just identically. Have you guys seen ever seen the what's this one called? The Rise application. Probably like a new award winner from this year. from the Apple Store. And this is, again, you can imagine what the surfaces are, what the transforms are, and it works identically on iOS as it does on Android. And this is the kind of thing, again, that it's really hard to even do in Quartz Core. But in the background of this guy is WebGL. So WebGL is something, you guys don't all know what GL is, but WebGL has recently been made available not only on browsers like Firefox, but also Google's Blink, and it will only be a matter of time this year before Apple does the same as well. So again, when we're talking next year about what it means to build a web application, we won't be talking about what we can do with with using physics on squares. We'll be talking about what it means to build something with not just dozens and hundreds of DOM elements, but millions of real vertices, shaders, and actual math. So that's going to be a really exciting time. Okay, now it's time for Q&A. A stands for applause, by the way. Yay! Thanks for having us, guys.
Thank you.
Yes, sir, you in the front.
You talked about building a Pinterest layout, and there's performance problems when you get into like infinite scroll and the number of DOM elements that increase over time.
Right.
Does Famous just handle that issue for you, or is there some kind of, or do you have to worry about it yourself?
So the scroll views that we built, I'm sorry, the question was, when dealing with this canonically hard problem, which is scrolling, and something that is a problem not only in like fancy futuristic applications, but even in basic like list style applications, how does Famous deal with scrolling for you, or do you have to deal with it yourself? Now, scrolling is one of the like really hard problems.
Well, not necessarily scrolling, but
okay.
The performance problems that come up when you get increasing number of objects in the scene.
Right. I think Famous does something pretty smart about that, doesn't it?
Right. So if you put everything, if everything's visible, if you actually make like a million visible surfaces at once, you can overload the system just like you can overload anything else. But especially with something like scrolling, where we sort of know your behavior, we know that when this is on screen, this is not on screen, you do need to do active culling to make that work. Right? So when you get into Pinterest, which is a 2D layout, it's easy enough to do like scrolling in 2 dimensions where you're culling on both dimensions. But with an arbitrary layout, that does get actually more tricky because you want to lay things out in this like isotope style pattern. So yeah, Famous has there are the principles in Famous to handle that, and we're building the kind of templates and layouts that allow that to be not an issue for you. Because you don't want to deal with that, right? You want to build your app. You don't want to like solve fundamental problems in like surface management yourself. We should do that. Yes, sir.
Could you apply Famous to say a tessellated pane and maybe apply a physics-based vertex shader to show physics at a smaller quantum, or is that maybe in the future?
So the question was, could we? Sounds like 2 questions, right? One is, can we apply Famous to a tessellated pane? And I assume if the tessellation is non-rectilinear, then we're looking at something like using GL or Canvas to do that. And in principle, yes, we can. And the GL is something that's coming out a little later than our initial DOM-based implementation. But sure, like the GPU only thinks in terms of surfaces, and GL communicates that to the GPU in its own way. When it comes to adjusting the quantum, the like delta T of physics, yes, that is also possible. We have our physics engineer in the back there, slunk down on the couch. It's all a matter of changing the delta T in the integrator that you're using to solve the equations that run the system.
I'm glad you're here to field questions like that, Dave.
And you can make it negative. You can run the universe backwards. It's really neat. Yeah. Was that your question?
By quantum, I just meant a higher resolution on the. But yeah, that answers it.
Right. I mean, I guess the question is, can you achieve higher resolution of
physics?
Right. So we can do the goal for any of these applications is 60 frames per second, or an update every 16.66 milliseconds. Any more than that, and you tend to get rate limited by the browser because humans can't really see at any, their internal clock doesn't work any faster than that.
Right. Really, what I'm getting at is, could we see these panes bend like paper?
Oh, could you see panes bend like? So these things expand in a rectilinear way. You can skew them, you can rotate them, but in terms of a curved bend, you need something like Canvas or GL to accommodate that. And much like Meteor doesn't care what it renders to, Famous is architected in such a way that any of the backends to which it would render are abstracted away. So soon, not yet.
Talk to you more.
Our physics engineer, Dave Valbin's in the back if you'd like to talk to him more and get a real answer.
And we have the ability to
All right, great. Thanks, guys.
Thank you.
Good job, Zoltan. Boom. Oh, yeah, we're releasing in 45 days, so you will actually be able to use it. Thanks.
Open source. Right?
Open source, yeah, that's true. Send checks to Fetterman at Famous. It's free, I'm just kidding. All right, thanks.
And there's some seating over here if you guys want. All right. If you want a seat, we got. Okay. All right, and our next speaker, our next featured talk today is from Slava Kim. Slava is a Meteor core dev. He was a two-time medalist for Kazakhstan at the International Olympiad in informatics. He coached his national team and produced a series of training videos for them after moving to the US. While at Collections, which is a YC company, in 2012, Slava authored the native Windows 8 client while also contributing to the Cocoa client and the backend infrastructure. And here's Slava. He's going to be telling you about some of the best practices around using Mongo in a web app.
Hi everyone, my name is Slava. As Jay said, I work here at Meteor, and I spent a lot of time working with MongoDB. Do you like MongoDB, guys? Yeah. I don't know, like, I spent so much time working with it, I learned how to love it. So, actually, this joke was stolen from Discover Meteor book. This animal is called Mongo, and they can bite you. But, you know, our Mongo can bite you too, so we are going to talk about this. All right, so the talk is going in this way. I'll open Mongo shell, connect it to the latest Mongo, latest stable Mongo. Wait, stable? Okay, never mind. Okay, so Mongo shell, and it's connected to some Mongo version, right? And I'll be showing everything inside shell and then explaining what happened. So let's start with some easy examples. I have several collections here, and one of the collections is people. And I have one document here. It's a person whose name is John Doe, and he has some address with city and state. And if I want to find him, I can just say, find me everyone with name John Doe. And yeah, I find him. So what happens if I want to find everyone with the same address as John Doe has? I would say address is state in California, and city is San Francisco. Wait, I didn't find him. What happened? Who knows what happened? There's a hint. We didn't lose all the data yet. Okay, here what happened. Looks like I typed California correctly and city correctly and San Francisco correctly, but apparently you can notice that in my address object, the first field is actually city, and then it is state. When I queried my Mongo database, I put them in the wrong order. I put state first and city first. Who would know? Okay, let's try a different way. I'll put city first. And now I find him. Yeah, we learned something. Okay, actually, you might think like, well, it's not very useful because you always can use a different syntax. You always can have like a dot notation, like address should be address.city should be SF, and same thing with state, and it will work. But actually, there are other places where it is important. So the lesson here is the order of properties does matter. And if you put them in the wrong order, Mongo just doesn't think they're the same thing. Because ECMAScript didn't really define how you can test two different objects for equality. There are other places where it is important in MongoDB. For example, sort specifiers. Whatever field you put first is more important for sorting. And collection indexes. Whatever field you put first will be the primary key for that index. And then it will use the secondary key in your object to resolve like the equal keys. So yeah, if your Mongo is not web scale yet, you can check that. Maybe it will help. Yeah, something learned. Okay, next thing. That was easy. This one is a little bit harder. You actually need to look at it. Imagine a database with a collection called places. And we have several objects, 3 objects, A, B, and C, and each object has an array field. It's called ratings, and they have an array of ratings, numbers from 1 to 10. And you can imagine it's something similar to Yelp, like you have ratings, fake or not fake, who cares. And I already have this data here. I'll do db.places.find, and I find all 3 of them. Now, let's say I want to sort them. I want to say, give me everything that is sorted by rating. And I'll get the least rating first. So it gave me some order, A, B, and C. I'm not sure why. Ratings. OK, thank you. Yeah, so it gave me some order, A, C, and B. Who knows why it sorted it this way? I can guess that Mongo took 1 from this place, 1 from this place, and 2 from this place. But I cannot know for sure. But looks like that's what happened. OK, now let's say I want to find all ratings. And I want to omit very low rated places. I don't want anything that is rated below 2. So I'll say, give me everything that has ratings greater than 1. OK, I got rid of C, because C had a low rating. But look, the order is different now. It used to be A and B, and now it's B and A. And who knows why?
Because there's a greater difference between B and 1.
There's a great difference between B. Sorry, what?
And, well, it's got more elements that are above 1.
It got more elements that is above 1. Maybe. Maybe that's how it works. Maybe it has 3 elements, that's why it's earlier. But I asked to sort in ascending order, so probably it's not right. So what actually happens, we can look at it later. Let's try 2. Now it's A and B. Let's try 3. B and A again. What if I try 6? OK, magic ended. OK, never mind. It doesn't work anymore. So what actually happens here, the way Mongo does it, Mongo takes all the integers it can find in locations field. Those are 1, 1, 2, 3, 4, 5, and 9. And it just puts them in a table and just assigns a corresponding ID to each number. It's like first one came from A, second one came from C. It just takes first 3. Because A, C, and B are like just every ID you can ever imagine, like in this collection. So what happens when I ask it for all locations greater than 1? It will cut off those ones. So we don't have ones anymore. We have 2, 3, 4, 5, and 9. And it will just take the first 2, B and A. Simple as that. And you can imagine then when we asked for greater than 2, it would take A and B again. And that's how Mongo works, unfortunately. Or maybe fortunately. Maybe it's useful. OK. That was 2. That's the third one. Everybody knows that sorting is fun, and we've just seen it. Mongo is especially interesting when you sort things. You also can sort things based on location. You can tell it, please give me all points around the point I gave you in a radius of 5 meters or 500 meters. So it looks like this picture, like radar. And imagine this example. We have a collection with 2 documents. And each document is a restaurant, and it has a set of locations. Location is a pair of dots on plane, 0 and 0, 1 and 2, 0 and 1. And I already have them in a database, obviously. I go to restaurants. I find them. We have them. And now I will sort on location and on locations. And I will tell it, give me everything that is near with point 0, 0 and 0. And max distance is some big number, so we take everything. So what I expected to do, I expected to give me both A and B, because both of them have some documents matching my selector, right? And they're probably somehow sorted. We already know that sorting, order sorting is not that important for Mongo. And OK, I expect 2 documents. Let's see. OK, sorry, I messed up, sorry. Locations, did I spell it right? Locations near. Yeah, sorry, I should have put it into selector. It looks right, and something is wrong. Sorry. OK, now it should do what I want it to do. No. Sort must be an object or an array. What does it even mean? Does anyone know what happened?
Why are you sorting?
Why am I sorting? Maybe I shouldn't sort. You're right. OK, now I got 3 objects. Yeah. Wait, is it good or bad? I think it's bad because I got 3 objects and I got A twice. I'm not sure whether it's good or not. Probably not, because last time when I asked Mongo to sort something, it gave me every document only once. Now it gave me some document twice. So if you ask your Yelp to find you some restaurants and you get some restaurant twice, maybe they use Mongo, I don't know. OK, that's the last one, I promise. You can get some drink after that and get rid of this Mongo knowledge. All right, so this is easy. It's not related to sorting. It's not related to anything like, OK, actually, it is related to Mongo. But everybody probably uses JavaScript in this room. And everybody probably learned the hard way what is the difference between null and undefined in JavaScript. So in JavaScript, as you know, null and undefined are the same thing if you compare it with double equals. It's not the same thing if you compare it with triple equals. Mongo brings it on the next level. So I'll show you how. Mongo uses this internal format called bson. And bson is like binary JSON. It looks like JSON. It also supports additional formats or types. And it's basically pretty much the same. The interesting part is, at some point, bson deprecated the undefined type. So you cannot use undefined anymore in bson. It means you cannot use undefined in MongoDB as well. And what does it mean? It means just all tools should stop using undefined. That's what deprecation means. Let's check it out. OK, I'll create a new collection called things. It is empty now. And I will insert 1 document. And I'll put I will set the field A to null, because we're working with nulls and undefineds. And I'll call it null set to null from shell. OK, it's still there. We didn't lose any data. That's good. And now I'll set it to undefined. I'll insert another object, and it will be undefined. And here it will be set to undefined from shell. OK, look, shell converted my undefined to null. It's good, because now, like, undefined is deprecated, and something should convert it to null essentially. That's good. Let's do something else. I don't know what it was. Let's insert a document that doesn't have an A field. No A field. In JavaScript, it would mean A is still undefined, because if you don't have a property, it's an implicit undefined. And I get it. There is no field. There is no A. So to be complete, I'll exit Mongo shell. And data is still there, I hope. And we'll use this Node.js script to insert another document, but from Node.js application. And as you know, like, Meteor uses MongoDB Node native driver to do that, to talk with Mongo as well. And we'll just use standard official NPM module called MongoDB. And we'll insert a simple document where A is undefined. And we already did it for Mongo shell, but I'll do it one more time, but from Node application. I will run it. Let's go to Mongo shell. Data should be still there. Thanks. and I get 4 documents. So I inserted 1 additional document. And you can see something that was inserted from Node app is null, is converted to null. So it's good. So now, if I ask MongoDB to give me all the documents where A is null, what do you think? What will happen? Who thinks it will return 1 document? Anyone? 2? 3? 4? Okay, some people think it's 4. MongoDB documentation tells us that null matches undefined and undefined matches null. So in my opinion, it should return 4 documents because implicit undefined is also undefined and it should match. Let's see. I got 3 objects. Yeah, as you would expect, it's not that easy. Otherwise, it wouldn't be here, right? Okay, let's see what are these 3 objects. Set to null from shell, seems right. No field, seems right. From node app, undefined, seems right. What's missing? Undefined from shell. But wait, it says null, right? It says null here. I just did it. I didn't touch my keyboard. I didn't insert anything. Like, it's still there. It says null. But apparently, it's not null.
Well, the question is, how do you remove a field from a document?
I don't remove a field from a document.
What if you need to? You have a document, previously you set the field to undefined. Now,
So the question is, how would I remove the fields?
rewrite the entire document.
And like, my answer is, I don't want to remove fields right now. Right now, I just want to take my data. Remember, removing things from MongoDB is much easier than getting it from it. Okay, look, I inserted undefined from shell and from from shell and from Node application. When I did it from Node application, it worked. I get it. When I did it from Mongo shell, like the official Mongo shell, it doesn't work. Apparently, it's not null. It's lying to us. Sorry, this one. It is still an undefined. And if you go to actual data on your disk and you look at it, it still defines itself as undefined. It's still lying to everyone. So yeah, don't insert undefineds from Mongo shell. I guess that's the lesson. That's all. So originally, I wrote a blog post on my personal blog because I don't want to post it on Meteor blog, sorry. There are other things that we find in Meteor every day because we work with MongoDB a lot. As you know, if you caught David Glass's talk about uplog tailing and how we use it to get real-time updates, we actually really push MongoDB to its limits. And we find a lot of little funny and interesting things. And maybe you would need it one day. You can show off, easily with that. So if you want, you can go to that URL. There are other things that I didn't mention in this talk. And they're not that interesting, but they're still important in your real life development because you can, get a bug. So yeah, that's all. Thank you. Any questions? I hope no. Okay.
What is the solution to the second problem you mentioned?
The question is, what is the solution to the second problem? What is the second problem? Sorting on the fields. The answer is don't sort on the fields. Don't sort on array fields. I mean, if you don't know what it does, don't use it, right? And, well, sorry, you can tell. Okay, never mind. I wanted to say something bad about MongoDB, but I love MongoDB. I cannot say it. The answer is simply be careful. Don't put a lot of stuff into your arrays. If you put them into arrays, be sure not to rely too much on the correctness. Sorry, bad advice, but I don't know other way.
So my question is, there is no way to do the sorting on the arrays, right?
You denormalize it.
Yeah, the question is, can you do it other way? Can you work around it? Yes, you can denormalize it. You can put it in a separate collection. Also, you can, if you make sure you never say greater than on that field, it will be fine. It probably will be fine. Just make sure you, fields in your sorting doesn't intercept with fields in your selector? Maybe that's the answer. It's really a hard question. So, another question? James?
So does the node MongoDB driver coerce undefined to null before it sends to Mongo? Or is it something even weirder?
Yes, James, you're right. MongoDB driver in Node does convert undefined to null before actually sending it to MongoDB, if I understand correctly. Looks like Mongo Shell doesn't do that. Mongo Shell does it the other way around. Whenever it sees undefined, it will convert it to null for representation, but it will not convert it when it will insert it. Maybe it's a bug of Mongo Shell. Maybe I'm just a bad person if I exploit it right now, but that's how it works today. Emily?
So does node Mongo driver, what does it do if it reads undefined out?
Emily asks, what does node Mongo driver do if it reads undefined out from database? I don't know.
I would guess undefined.
I would guess it does it right. I would guess it works. We can try.
So node Mongo driver does exactly the opposite of what Shell does?
I wouldn't say it's exactly the opposite. I mean, I cannot reason about it anymore. How do we do stuff? Sorry, I don't know how to node. Other questions? Sorry, anyone? Okay, thank you.
All right. Next up, we have a special announcement before the lightning talks and all that start. Avital Oliver, one of our core devs, has a special announcement for all of you. So,
Thank you. Good talk, Slava.
yeah.
Am I hooked up?
Yes, you are.
Yeah, okay, great.
Turn
just
off
wanted-
Flux.
What?
Turn off Flux.
Turn off.
Okay. Oh, it's fine. Okay.
I want to talk about Spark today, Meteor's live page updating engine. It's great. You sometimes get errors like these. I'm sure everyone here has tried it and loves it. And once in a while, it's just a surprise. You need surprises in life. For the past almost year now, we've been working on a replacement for Spark. It's a totally new system. We're getting rid of Spark. It's now the old live page updating system, replacing it with Blaze. We used to call this Meteor UI. Maybe there will still be something called Meteor UI. Internal code name is Shark. That's the branch on GitHub that it's built on. And it's ready. So let me just release it real quick, if I can.
Embiggen.
What? Embiggen. What's Flux? Quit Flux. Now you're all awake, right? The question was, is it really, really ready? The answer is yes. We want to improve some of the error messages, but yes, it's ready. It's done. So while it's publishing the release, let's keynote. OK. So what are the benefits of Blaze compared to what we had before Spark? It's easier to use. There's no isolate, constant, or preserve directives that a lot of people struggle with. The rendered callback only fires once. It's a simpler way to understand the system. It works better with external modifications to the DOM, like jQuery plugins. We have a sample somewhere on YouTube that shows how you have a reorderable list using jQuery UI sortable, and you basically integrate it in the simplest way possible, and it just works. That's not going to be true for every single form of external modification, but a lot of them will just work. Native SVG support. So a lot of people use something like D3 to create visualizations, but turns out SVG is a fairly simple language, and if you could just write SVG that updates dynamically, you can create animated bar charts or visualizations. And we have another sample online you can find with an animated clock written in something like 20 lines of SVG template in Meteor. It's very simple. It's just more predictable behavior. Blaze knows to only update the parts of the DOM that have changed. So you can reason about what's actually happening, whereas Spark, what we had before, re-rendered your templates and then did this diffing that was kind of hard to reason about and was very confusing at times. And due to the way it's built, we only apply the minimal DOM operations necessary. What we had before, Spark read a lot of DOM every time you render a template, and that causes a page layout, and that means it's slower. What we have now is basically, in the limit, the fastest possible rendering engine. A little bit about under the hood. It's a totally new system. Everything is like rebuilt from scratch. One relevant example is that now simple templates get compiled into a domain-specific language we have in JavaScript that we call HTML.js. So this handlebars template renders into this code, which basically tells Blaze what parts are static and what parts can be updated dynamically. And then when it renders, it keeps track of those dependencies automatically and updates them when the data changes. One of the interesting consequences of this is that you can have any other templating language. It's not just handlebars. You can imagine some fake templating language that I invented here that would compile to exactly the same HTML.js code. And so now, in order to build some additional templating systems, all you have to do is build a parser that compiles that language into our HTML.js code. And in fact, somebody actually already built a Jade plugin. They didn't talk with us. They just announced it one day. If you go to Atmosphere and look for a package named Jade, not Jade-something or something-Jade, just Jade, it works. It doesn't support all the features of Jade yet, but he's working on it, and you should just try it out. The cool thing is people have tried to do this with Spark many times and failed. With Blaze, somebody just did it, and it works. Blaze is only the first step of additional projects we want to do to improve the Meteor UI story. There's a lot of features that everybody wants, like animation, reusable components, per template reactive state, forms, two-way data binding, inline expressions, server-side rendering. All these things we've talked about for a long time are now easy. You can just build them. What we had before, sorry, when I meant we are now set up to build these features. You could also try. But what we had before was just basically not a good foundation to build these things. Upgrading your app to Blaze is easy. Most APIs have not changed. We spent a lot of energy to try to do that. A future version might change some APIs to make things more performant or easier to use. But this version is supposed to be as simple of a transition as possible. Let's see how that works. Now that Blaze RC0 is released, I can go to bigger? OK. So I'm now on just regular Meteor. This isn't Blaze RC0. I'm going to create an app that is the parties example. Sorry, let's kill the old one. OK. All right, so this is the example parties app. Just real quick, I'll create a user. Right, OK, this is the old app. Now, I'm going to go into that same directory and run meteor update -- version Blaze RC0. Release, thank you. OK, updated to Blaze RC0. Let's run it now. Oh, it's already running. OK. Oh, restart Meteor to test the use in your release. OK. Let's see what happens. Oh, shit, it failed. Okay. What is it? Use greater than login button instead of login buttons. OK, that sounds pretty simple. OK, what do we have here? Login buttons. OK, let's do this. Oh, wait, that was cool. OK. Wait, does it work? Oh, interesting. Wow, that was pretty cool. Wait, I got another thing here. What's it? Constant is now unnecessary and deprecated. Oh, you're right. Let's just get rid of it. I hated constant. I never understood how it works. Oh, that's it. Well, not bad. Oh, why bother? It's awesome. Most of your apps will not have to be ported almost at all. If you do fancy things, if you have block helpers that return HTML snippets and you want those to still be reactive, you're going to have to update them to be templates. And we actually have instructions, and there's a link at the end to exactly what you need to do to port some of the more advanced uses of our APIs and apps or packages. Use it now. This is the time. 0.80 is just around the corner. It's going to have Blaze. Going forward, Spark will be gone. Now is the time to port it, use it in your apps and your packages. Some packages might not work because they need to be ported, like forms packages, for example. Apply pressure on the authors of these packages. Make them fix them quickly. I know almost everybody uses Iron Router. I've not tried this, but I asked Chris Mather what's the status. He says the Blaze integration branch on Iron Router. If you also add an additional package called Blaze Layout, it should work. And I know at least one example of somebody today who did that. So it is not false, and maybe there's some caveats. I don't know. Try it out. If there are problems, talk with the authors of Iron Router. So short story, use it now. This is the wiki page to how to use it. If you're trying it out and you have issues, talk with us on Meteor Talk. There might be bugs. We've fleshed out a lot of them. People have been using this for several months now in preview releases. They reported many issues. We've got great feedback, and we worked on those. So it works. And if there's some problems, they're going to be minor ones. One more thing, you want to use it outside of Meteor. A lot of people talk about Meteor being monolithic. We're trying to break that perception. We're working on packaging Blaze as a standalone component that you can use with your existing web app if it's an old Ruby on Rails or Java app or whatever it is you want. One more thing before I forget, let me just send out this email. OK, cool. We just released Blaze RC0. And that's it. Questions? Yes?
How much could you benefit of using Blaze outside of a Meteor application?
How much can you benefit from using Blaze outside of a Meteor application?
Or what would you have to sacrifice if you weren't using Meteor?
If you weren't using, well, one of the main things you cannot get without Meteor is latency compensation, which is that any action you take gets enacted on the client immediately without waiting for a server round trip. That's part of the deep integration technology that Meteor supplies. So you can use Blaze with your own REST endpoints and do AJAX calls, but it'll still feel like an old, slow web app where you take an action, you have to wait to see the update.
That's still worthwhile, you'd say?
I mean, I'd say if your options are incremental improvement on an existing app, it would be better to use Blaze than to continue using whatever technology is out there. And maybe that's a stepping stone towards transferring the whole project to Meteor. More questions? No? Yes?
What are the rules now when created, destroyed, and rendered fire?
Yeah, the question was, what are the rules as when the template lifecycle callbacks created, rendered, and destroyed get called? The rule is created is called before it's rendered so that you can set up any state needed by helpers or other parts of the process. Then rendered is called once when it's on the DOM, not again. And then destroyed is called once when it's removed from the DOM. Yes?
I heard a rumor that data contexts aren't passed down to inlines or included templates. Is that true?
The question is, I heard a rumor that data contexts aren't passed down
To templates that are included in a larger template. So if you have
the data context rules have not changed, really. I'm not sure what you mean.
good.
Yes?
I would like to ask a follow-up question on the rendered callback loop.
Uh-huh.
I would like to, at the moment, if anything on the template changes, that callback will get triggered. Is there any equivalent loop that you can now use that if anything has changed on your template, that will get triggered?
Yeah, the question is, the old rendered callback may have been useful sometimes if you want to act on any change within the boundaries of a template. And is there a replacement for that? The short answer is there's no direct replacement. If you want to depend on specific values changing, you could set up your own deps.autorun for those values. The general way it worked before when any change in template fired the same callback was almost always confusing. So I'm curious to hear from you later if that works out for you, just setting up the auto run around the specific values that you need changed and then acting on those directly. So, Slava?
I've heard a rumor that you cannot access the data context of the parent template.
The
I don't know,
rumor?
it's a rumor.
The rumor is that you can't access the data context of a parent template
With dot dot.
with dot dot. That's false. You can do dot dot. Okay. What you can't do, which you could not do before, is access that context from a helper if you don't pass dot dot as an argument, or from an event handler. That was not true before. That is not true now. Was true before. That is true now, and that will be fixed with some later improvement that will also entail an API change. All right. Thank you, everybody.
Thank you. All right, and while we're doing a little transition, we have a few extra seats up here if people who are standing in the back want to grab a seat. And could I have Jeffrey Verdurnikov, Jeff Chandler, Kenton Varda, Mike Reese, Camille Kozak, and Ted Blackman over in the back so we can start miking you up. How's it going? Such excite. It sounds like I'm audible.
Where should I be?
Back there. Oh, and if I'm audible, hey, if people who are currently watching from upstairs want to come down, we do have some seats for you. Yeah, there.
You're telling me I'm good at complaining about activity.
Oh, and one more thing. Right, hold on.
Like also one of the cool things is like
They'll control volume and everything. Hey, you should mute me when I'm not.
Either inside of a pocket or clip it to something. All right, great. And then you've spoken before, so you know just don't ignore the mic button and turn it when you're done. Yep.
And when are they starting?
In a few minutes.
Do I turn it on or is it?
They'll take care of it.
Oh,
Yeah.
wow. So
They'll turn it on for you.
it's
You don't have to turn it on or off. If you want, you can.
let's all grab a seat. Folks who are standing in the back, we have a lot of seating in front since a lot of our speakers are in the back. So especially folks in the lobby, come on in and grab seats in the front.
All right, we're about to begin. If everyone could grab a seat.
Please grab your seat and have folks who are near you standing up sit down too. We have additional seating over here, so no need to stand if you don't want to. And Bill, your head might be in the way. You might want to take that seat. All right. Lightning talks. All right. First up is Jeffrey Bernardikoff. He's going to be telling you about Houston Hook, a project formerly known as zmongo admin, and he's going to be telling you about using Houston admin hosted externally on Meteor.
Right. Well, actually, it's a bit of change of plans. I'll just be discussing a use case of Houston, but it's still going to be on Houston. So I've given a talk about Houston before, previously known as zmongo admin, and Alexei, many of you might know him, has also given a talk about Houston. And what Houston is, very simply, is just an atmosphere package, a Meteorite package, that just plugs straight into your app and lets you access MongoDB without having to insert undefined from the terminal, or insert null from the terminal, or whatever else Slava was doing at the time. So it lets you just view your data. So it was actually very useful for a production web app that we were using at PennApps. So PennApps is a hackathon hosted at the University of Pennsylvania. It's actually kind of comical because Houston was built at a Meteor hackathon here about a year ago, or nearly a year ago. And here we're using it at another hackathon that I run called PennApps. So all it is this is just a very simple Meteor application that just, you have a form, you type in your email. So I'm a Penn student, Jeff, Penn, LinkedIn, username. And then you just submit this form very simply, and then it gets added to like a big collection of applications. So we actually had about 2,500 applications to our hackathon, and we collected over like 4,000 emails. It's kind of ridiculous. And we needed to figure out a way of very easily ranking the applicants. So very easily ranking the applicants and then like figuring out like which we only admitted I think 800 out of these 2,500. We needed to figure out like which third to admit, which third to put on the wait list, and then which third to completely reject. So Houston actually made it very simple to do this, and all it took was just Meteorite or MRT add Houston and then just deploy it. And Houston gave us automatically a /admin route that lets us see every collection and number of records we have in each of these collections. So these are emails we collected. We collected about 4,000 emails, and they're all here, all in this huge collection of emails. Apparently some of them are not legitimate emails. Here's someone saying hello to me, apparently. But anyway, these emails will be are farmed so that we can have more applicants next year. And then the applications themselves are right here. So here's the additional info, here's the email of the person, here's their GitHub, here's their LinkedIn that they submitted, here's their name, school, and some team info that some people submitted. So we had a committee of about 5 or 6 looking at these applications, and each of them were assigned about 500 to 600 applications. And Houston actually made it very easy to rank these applications. So what we did is we just added a field called first rank, I think. Rank. We just added a field called rank and a field called second rank, as you can see here and here. And Houston hooks onto any time you add a new field to a document, and so it defaulted all of them, I think, to either undefined or null, or I guess now I know that they're both the same. So defaulted to null for every document in the collection. And then we had our committee members go down and rank all the people, and it was very simple to search. So we had some people do the A's, every applicant whose name started with A Get some people to do Bs, Cs, and so on. And this is just a very simple use case of Houston. If you want to check out Houston, it's on Atmosphere and up on GitHub. I think that's it.
Questions?
No questions. Nope. No question. Go ahead.
Did you use any packages for that table editing?
The question was, did I use packages for table editing? It was just very simple Bootstrap CSS that I just inject into whatever your CSS is. So I remove all of the CSS of the app itself. So if you saw like the application had its own CSS, I remove that and then add Bootstrap. Nope. No other questions? Cool. That's Houston.
Next up, we have Jeff Chandler. He's going to be telling you about a Meteor client for Java.
All right. How many people in here love writing in Java? Yeah, all right. So sometimes you have to integrate with legacy systems, whether it's a big enterprise application, and Meteor is awesome. You want to do this really quick thing, and unfortunately, you have to deal with all this other stuff. And that happened to me, and there's always these data integrations you have to do, and it's nice when you can integrate with something that's faster and easy to develop. So I was also working on this point-of-sale application that was required a lot of peripherals, receipt printers, magnetic stripe readers, thumbprint readers, and they all had their drivers either in .NET or Java. So basically, a web app was out of the question. But the management of it, we wanted to put all in the web, in the cloud and all that. So, because there's all these screens, lots of stuff, most of it can be pushed off to the cloud. And so that was a better thing to do in Meteor. Unfortunately, we had to do the app in a thick client. So we created this Meteor DDP client for Java and tried to create a seamless experience for it all. So if you ever have to use DDP in Java, this is how it works. So basically, I reduced DDP into 3 major parts, which is the connection, the WebSocket handling, and how really your message handling. All the DDP messages, you want to serialize them, deserialize them to Java objects. There it is. Then there's the whole subscription thing. What are my collections? What gets updated? How does that map to and from? And then there's the RPC. I want to do calls, do the whole update stuff. Subscribe is actually RPC, so they're kind of fit tightly there, but tried to design the API in a way that it's easy to use. So it's pretty simple. Created a couple sample apps. Oh yeah, if you guys want to check it out, it's there's a URL. I can send that around if anybody cares. If there's more Java developers somewhere. So basically, I wanted WebSocket containers provided by JDK 8 and above. So you have to hack around your WebSockets if you're using older Java. Then the next big thing is your message converter. You want to convert your Meteor messages into Java messages. And so you think, why didn't I just bury that in the client? Because there's only really one way to do that. But I wanted it to be extensible. I mean, maybe one day we want to use a binary format like Google's protocol buffers. You could actually do that with the existing Meteor and have serialization that way. So try to keep everything to an interface as possible. And then really the big part is your message endpoint. And that's what does all your work. You subscribe listeners to that for all your Meteor messages, and works pretty well. I've only got 30 seconds remaining, so I'll just give you a demo. I wrote 2 quick apps that use it. So this in the terminal is a command line, super easy, like 40 lines of code. Here's a Meteor template, and I'll do a tab. So this was for a point of sale system I did just Haxa from. That's an update, that won't work. 455. So I'll create something. You can see it came over here. Oh, shoot. You can see it came over here. You can't see where I'm pointing. Here and up here. If you change, this is Java client, by the way. This is Java FX. And if we go and change it, we can see the messages being pushed through. All right, I'm out of time. There you go. So, hit a tab. Any questions? Yes? Yeah, actually, I did keep everything abstracted. So there's a subscription adapter. So the subscription adapter for like the client Meteor would be transform it to mini Mongo. I did a map adapter for the sake of this demo, but you can really inject anything that implements map. So HBase does. So Hadoop would be a very easy integration. But if you want to do a SQL one with an in-memory database, or been looking at something to do a clustered environment with JGroups or Memcache or something like that, you can inject any sort of provider to be what your actual storage is locally.
So what does the library do for you versus where does it leave off for you?
Great. Yeah, so basically this takes... Oh, yes. What does the library do for you, and what do you have to do on your own when you're using the library? So this provides a basic way of handling a connection to Meteor, your Meteor app, and handling messages and your objects, your collections, and gives you an interface to your API, or your RPC APIs. So you're going to have to handle spinning off a thread for a WebSocket listener. If you want to do reconnects, you're going to have to handle that in your application logic. There's lots of different arguments for different ways that you could go about that stuff. One thing I didn't do is eJSON, because Java already serializes or is already strongly typed. So I just didn't do it. So if you're pulling in JSON stuff, it looks like strings because that's what they look like in JSON. Outside of that, you can add hooks, handlers to really any event that's in Meteor. So a typical design practice you would do in like a service locator or enterprise integration pattern would be to have an adapter or a dispatcher that gets your Meteor events and then turns them into domain-specific events. And then that way your application can see what your application is looking for instead of Meteor-y stuff. All right?
Thank you.
Sweet. Oh, yeah. It is github.com/SailorJeffrey, SailorGeoffrey, and then /DDP client Meteor. This?
Yes. Relax, it'll be fine. Do you have an HDMI port?
There we go.
All right.
Yes.
All right, next up we have Kenton Varda, author of Protocol Buffers and Captain Proto. And today he's going to be telling you about Sandstorm.io. What if users own the servers?
Okay, so I'm going to talk pretty quickly here and show you something that is just started working a couple of days ago, and only like 3 people have seen it so far, and it's pretty hacky, but hopefully it won't totally fail on me. So what we're looking at here is, you probably recognize as the Meteor demo to-dos app. So let's say we don't know what this is, and I'm browsing around the internet, and I come across this. And I want to use it. I like it. I actually want to use this to organize my to-dos. Well, I can't. There's a few problems. So if I don't know the developer, or I don't trust the developer, then I don't really know if they might be spying on my data or passing it along to the NSA, Or I don't know if this app is going to disappear tomorrow and I'm going to lose everything. And I don't know if it might have security bugs that mean that people are going to be able to hack into it and mess with my data. In fact, in this case, this app appears to have no security whatsoever, so that's a pretty big bug. So what I'd really like to do is be able to install an instance of this app to a machine that I control, that only I can access, that can protect me from these things. And as it turns out, this particular app lets me do this by providing this link here to install me on Sandstorm. So I'm going to click on that. Now it's going to start downloading the package. So now what you're looking at is my personal Sandstorm instance. And this, the UI is written in Meteor. It's, of course, on top of a lot of other stuff under the hood. But Meteor made it really easy to develop. So what we have here is up here I have sort of a start menu-ish thing that looks really ugly because I'm not a designer. These things here are documents that I created with a different app that I already have installed, and I could potentially create a new such document here. But I'm not going to do that right now because I really want to use this to-dos app. And since it's downloading pretty slowly, I'm going to cheat and just download it locally here. Cancel, try again. OK. And confirm that I do want to install this. OK. Now if I go in here again, I have the ability to create a new to-do list. When I click on that, I'm going to give it a title. And now it is launching a new instance of this server on my Sandstorm server. So, so this is obviously, well, it's a fresh database, so it's populated with the example data that this example comes with. But I'm just going to make some changes. And then I'm actually going to create another to-do list. To-do-to. And the interesting thing here is that each of these instances that I'm creating here is running in a separate server-side secure sandbox that prevents it from talking to the rest of the world unless I give it. And so the app actually cannot spy on me or talk to the developer or disappear because it's running on my own hardware. And I'm just about out of time, so that's about all I can show you. So if you're interested in developing for this or using it, check out sandstorm.io. It's all open source. There's some mailing lists to sign up to. Any questions? Me? Oh, yeah, so who's handling security on this? I mean, what do you mean? Well, no, you can run this. You can run. I mean, it's open source. You can run your own instance. The technology under the hood is the same Linux containerization technology that underlies, say, Docker and LXC, but I'm using the kernel features directly. And then client side is not actually sandboxed yet, but in the future it will be using HTML5 sandboxing and content security policy. What kind of apps can be hosted in Splashly? Say it again? What kind of server applications can be hosted? This is, of course, oh yeah. So the question is, what kind of apps can you put on here? Is it restricted to Meteor? And the answer is no. It is a native code sandbox. So anything that runs on Linux, any tech stack that runs on Linux can potentially be ported into here. For instance, I have these documents here that aren't. So this is an example of Etherpad, which is not a Meteor app. It was originally written by someone who now works at Meteor, but yeah. Yeah, so what if you want a collaborative app? Yes, so I don't have those features yet, but one interesting thing about this platform is that the platform itself can handle sharing. So the app doesn't have to know anything about how to authenticate multiple users, and that can all go into the platform UI. You know, this top bar here, you can have like a share button, and yeah.
Any other questions? All right, cool, thanks. next up we have Mike Reese. He's one of the authors of Mad Eye, which some of you have seen at Devshop before. And today he's going to tell you about meteoric mocha. And you are looking for this.
I'm going to talk about a testing package that we've spent around a year working on every now and then. And you can see that on this is the beta of Atmosphere, which is awesome. If you haven't checked it out, I encourage you to do so. You can see sort of the history of the project here, the GitHub README here. I want to talk a little bit about our philosophy with Mocha Web, which is just that testing with Meteor shouldn't be a really complex thing. And we basically just want something that could bring Mocha into Meteor. So if you look at this here, this is kind of what we want tests to look like. So this, you might be thrown off a little bit by the CoffeeScript or the weird describe it behavior syntax. But if you look at the actual code that's in here, you can see that you're just doing your normal Mongo queries. And you can do things like access the session. You could conceivably have auto runs inside of these tests. But the important part is that you can just be using the language of Meteor, and your tests are not going to end up being a lot of code. The thing that we added recently, though, that I wanted to talk about today is the ability for server-side tests. So up until today, you've only been able to use Meteor on the client side, and if you wanted to test any server-side behavior, you had to call out to other methods. So you can see that this file is inside of a server component, which means that this test is going to be run on the server. And if we go into the terminal here, you can see the error message from one of the failing tests right here in your console. So it's running on the server. And furthermore, right here we see the client-side test, which is passing. Here we see a passing server-side test, and here we see a failing server-side test. And we can change any of these tests, and they'll update in real time. So let's make this this test here pass. We should be able to see it pass. So yeah. If anybody is curious about sort of how it's working behind the scenes, this is still very new. It has been released if you want to try it out, but you're probably going to run into a few minor bugs here and there. And if you do, please let me know because we want to fix them. I think that's about it. Thanks.
Questions?
That's an excellent question. How do you put your tests to the side so they don't get into a deployed app? So right now, the package basically looks at an environment variable. And if the Meteor Mocha testers is set, then the test files are not included in the package. Sorry, I said that backwards. If it's set, they are included in the package. If it's not set, they're not included. And it is a little bit of a fiasco right now to switch between the testing environment and your sort of normal dev flow because you have to rebuild the package whenever you want that to happen. You can't have the package exist in two states at the same time, one with test and one without. But hopefully we're going to be able to work around that in the near future. And if that's confusing, talk to me afterwards. Anything else? All right, thank you.
And next up, we have Kamil Kozak. He is one of the founders of Entai, and he's going to be telling you about a better way to connect things. First.
Okay. Okay, guys, have you ever tried to build application like that? That we have also communication between your own application that are running on mobile or on your website and real life objects, or like the demo we are having here that I want to present now. You can all log, for example, to this website that's called chat.enti.com, and there is a small piece of a hardware that will show you automatically all your messages you are writing on your Meteor application. Yeah. The platform we are working on is designed to be the tool for hardware and developers that want to connect real-life objects to their web applications. I was working for many years at university with students that simply wanted to build they had crazy ideas and they wanted to build some cool stuff with their own hardware and connect it to the cloud, but they simply didn't have skills to do that. That's why we decided to build Enti. Enti is a platform that allows you to do such kind of crazy things in few lines of code. Let me show you how it works. I don't have connection problems. Okay. You can add any amount of hardware boards to your account. Once the hardware is added, you can create any amount of software application on top of this hardware. And you can push the code written, of course, in JavaScript directly to your hardware. I have here a small piece. This is the example and the device that is over there. We can automatically push the code so the LCD will blink 10 times per second. The code is pushed automatically and it's working. Yeah, so you can see you can build embedded. You can start programming embedded devices with the same language you know and the same language you're using every day when you create Meteor applications. Now the goal is to provide this tool to everyone. We are a small company in Poland that already raised some money, and we are trying to raise our idea now here in the Valley. And we will see if we'll manage to successfully accomplish that in the near future. The goal is to provide you with a tool that will allow you to create such crazy things in the near future extremely fast. I think that's all. If you have some questions, I can answer everything. Yeah, you have to install small piece of our software on your Raspberry Pi, connect it to the internet, turn it on, and it's up and running and visible already in the cloud. You can, from this moment, you can always start to program it, push the data to the server. We are providing all the backend services that will consume that data without any limitation on the throughput. And on the other hand, you can write your own Meteor application, use standard DDP protocol to connect to our server and consume the data. So you can simply create your own dashboards to visualize the processes that are simply coming from the hardware. Yeah, it simply shortens the way and the job you have to done that has to be done to accomplish this task. So you can create your prototype in a matter of minutes or days, not weeks or months as it's now. So if you have an idea of building a hardware and to build it as a web-enabled device, you can do that in a matter of minutes.
I think this would work really good with like robots or something.
With what?
With
robots. Yeah, you can reprogram robots in real time, to be honest. But if you want to create other kinds of devices, that are also fine.
So can the data go the other way? So if I had like an Arduino board that was measuring something, could it be feeding to some?
Yeah, otherwise it's even simpler because you always can easily push the data from the device to the server. Yeah, and that way it's also working. That's the example with the bulb and the lamp. So you simply push the status of the lamp from the hardware to the server, and it's also working. That's why we are now focusing on unlimited throughput on the server side.
Last question.
Can we use it without deploying to your server, like registering it to this service and turning on?
Yeah, there are two parts of this service. First one is this software stack that runs on the hardware, and it will be open source in the near future. And the question was if we can run the software as a standalone without our services at the backend. Yes, you can program your own devices with use of this of our stack, and you don't have to use backend services that we provide. But you will simply lose the possibility to push the servers with your data and to analyze that data. But yes, if you create the application that is running on the hardware, it will run without our backend services.
One quick question. How does this work with like sensors?
How does it work with sensors? To be honest, we are providing 3 different types of connectors. First one is standard DDP that you are using in Meteor. Second one is standard RESTful services, and third one is MQTT transfer protocol that was designed especially for sensors. So you can choose any of those 3 communication protocols to push the data from any kind of hardware up to the cloud, and we will be able to provide you your own application with the readings from those sensors. So yeah, you simply can connect any device that is out there to our cloud, and we will be able to provide you with the data in your own application.
All right, next up we have one last lightning talk. Ted Blackman here is a hacker at 3Scan, and he's going to be telling you about slicing brains with Meteor.
Hi there. My name is Ted Blackman. I'm with a company called 3Scan. Let me see if I can blow this up a bit. So here is 3scan.com. We make microscopes that do what we call serial sectioning microscopy. So it's a little bit like a 3D printer running in reverse. What you do is you give a cubic centimeter or so of tissue, brain tissue or other tissue, put it into the microscope, and it slices off the top. And as it slices, it has a line scanning camera that images the slice. And then we do this over and over again until we've consumed the sample, slicing it about 1 micron thick. And then we can do a 3D reconstruction and get to data like this, where you can see this is a data of the microvasculature in a mouse brain. You might be wondering where Meteor fits into this. A lot of people do. We use Meteor for the control. So to actually control the microscope, let me blow this up a little bit too. Or not. Here we go. OK, so this is the user interface for controlling the microscope. There are a number of settings over on the left for controlling the bounds of the sample. This is actually running all locally on my machine. And so that's why it says sim up in the top. So if I go ahead and click slice face here, then if this all works correctly, you'll see this is a representation of the knife moving, slicing across the top of the sample. And so this is just a simulator. But here's the actual interface to the real device. And on the real one, you can see that there's these images here. And these are representing the data that we get off the machine. So these actually populate. This is using a library called Leaflet, which provides something similar to Google Maps, where you can zoom and pan around. And so as you're running the microscope, there will be these new ones that pop in, new strips of data. And one of the interesting things that we've done, similarly to the earlier talk about the Java DDP client, is that we actually have a cluster of machines that are all running worker processes. So here we are. So each of the 4 brain slaves. So this is a process manager that we wrote using a Python DDP client. So each of these machines has a process supervisor that maintains a DDP connection to the Meteor server, and it is told which processes it's supposed to run. And it also reports the number of statistics back, like the CPU and memory usage, and whether the processes have crashed and how many times they've crashed. We do continually break this. And then and you can add a new process onto a machine, like so. So now that just by dragging it from the left onto brain slave 0, we now have that process running. I'm going to kill it because we don't actually want that running long term. So the way this works is that each of these machines is actually a Meteor user. So it authenticates using Meteor's auth system, and then registers itself. And so we can just dynamically add machines to our cluster as we install them. Thanks. There you go. If you go ahead and email us, you can email ted@3scan.com, or, the question was, where can you get the Python DDP client? We haven't released it, but if you email us, we can send it to you probably. We just haven't gotten around to open sourcing it really. One thing we did recently that was pretty cool was we implemented DDP Reconnect, which was a lot harder than it sounded. Yeah.
So you say you're actually using Meteor to control the scalpel?
Not directly. So we use Meteor for the, the question was, are we using Meteor directly to control the knife?
I mean, not directly, but to communicate between the robot?
Yeah, sure. I'll give you a very brief overview of the sort of topology of the system. There's the Meteor server, which serves this website, which is the user interface. I can click a button here, which sends a Meteor method to the Meteor server. And then that Meteor server communicates with what we call the KESM process, the knife edge scanning microscope process, which is this one here, running on a different machine. So that's the machine that actually has the stage and the camera attached to it. And that's a Python process that controls the actual hardware interaction. But then it maintains a DDP connection to the Meteor server and receives commands and reports back data. It also, once it gets an image, so it gets an image about once a second, and it's like 4,000 by 12,000 pixels, something like that, then it shunts it off to the receptionist down here on another machine, which is basically the load balancer, which then distributes it out to one of any of these image tiling and image compression processes on these other machines, because we store the images actually locally in a big RAID array, and because it's just a lot of data, and so the images have to be compressed. It's a lossless PNG compression, and then also they have to be tiled into much smaller pieces so that we can have this this kind of user interface. These images here are actually made up of many tiles of smaller images. So once those tiling and compression processes finish, then they go and talk to the I/O thread, which just writes it all to disk. And it's important to write it all sequentially, it turns out, because as Matt, my colleague, is very fond of saying, it turns out that at some point computers are just a bunch of spinning rocks. And so you really want hard drives to write like this, not like this. Does that make more sense?
All right, thank you.
Thank you.
All right, And for our friends online, don't forget to subscribe to our YouTube channel. And one final announcement, don't forget to sign up for your Meteor accounts. You don't want someone else to grab your favorite name. Next Devshop is March 27th. And you can sign up on Meetup if you are going to be in the Bay Area. It's open now. And we're going to be live streaming that one too. And question, yes? Please come talk to us afterwards. Cool. Any other questions? All right, thanks. Can I have my tablet?
Yeah, what?